So I figured about 72 pounds of force could lift a 5-pound ball. For a 10-pound ball, about 180 pounds of force. In order to lift it with authority, just to hold it would be about 100 pounds, but I figure you gotta get close to doubling that to lift 10 pounds. So 180 pounds of pound-inches of force for the servo torque for the bicep would be my ideal goal. The force calculation roughly is 7.8 times amount to lift, and the bicep force needed to hold 9 times amount to lift. Okay, 7.8 is the bicep force needed to hold, 9 times the weight at the end is the amount to lift the bicep force needed. But to lift it with authority, I imagine it'd be closer to like 15 times, like double that to be safe, because you don't want to stress out the servos either. So I went through a whole bunch of servos here. A typical motor, servo motor, is 5 volts. They're pretty much all 5 volts, most of them, and between 4 to 6 volts, I should say. So 5 volts is just my average between the 4 and 6, because battery life will change the voltage. If the battery is low on charge, the voltage will go down. So I figured 5 is a good average. And at 5 voltage, most have 3 pound-inches of torque, just a standard servo. $30 is the general price. So you're getting $10 for 1 pound-inch of force. And so 100 pound-inches of force for a bicep would cost $1,000 for the typical motor, and it'd take 30 motors to power just one bicep. And I don't know where I'd fit them all. But fortunately, we have here a high-tech HS 7955 TG ultra torque titanium gear digital servo. That has 5 volts, 19 pound-inches of torque. It was very highly recommended on some of the larger scale RC car forums. 4 of them could power a bicep. So it's $120 per motor. 120 is 19 pound-inches of force. And $6 for 1 pound of force. It's much less than the $10 for 1 pound. And so 100 pounds of force bicep is $600. $600 for bicep is much less than $1,000 for a bicep. It's still a lot of money, but it's a good deal. But we have here 12 pounds of force, 7 of them. These MG996R Metal Gear Digital Torque servos. I actually heard a positive review of these on YouTube. I'm definitely going to use these for the fingers because they're about $8 or $9 each. That's shipped to your house from Hong Kong. You really can't beat that kind of pricing. 7 of them would power bicep, theoretically, but this could be like 12 pound-inches of force. Might not be actually what they make. It might be more like 9. Who knows? 7 of them for a bicep. That's quite a few. We'll see if we have room in the bicep for it once we add all the other wiring and stuff. But this is so cheap. $8 times 7. That's about $67 for the 100 pound of force bicep. That is the best price. Now, these don't have the titanium gears like this one, and they're not as raved about, but I heard they're pretty quality, so I might go with that. I'm going to start off trying these out on the fingers, seeing how good they are. That might be my solution, just tying 7 of them into the bicep. Actually, the bicep works in the human body with many, many fibers of muscle pulling. So having many, many servos pulling strings that are connected into the forearms will be a lot like how the muscles work anyways. So having them work together could really work out. Now I have some other ones that I compared prices with. None of them really had the ultimate combination of price and force. The MKS DS 1210 titanium gear standard digital servo. It's got high torque and high speed. It's $36 per motor. I need 12 of them. Okay, that's too many for a bicep. But these might not be bad for the fingers, although still $8 per motor. I mean, that's a third the price, less than a third the price for these. So the MG996R might be the only servo I use, really. But I thought it was interesting. If I was running into space issues or if I wanted to really upgrade the power someday, these high-tech HS 900 SGS servos are 12 volts, 62 pound-inches, very fast, 62 pound-inches compared to 12, compared to even these titanium ones that are only 19 pound-inches, 62 pound-inches, but they're higher voltage. I think the Lynx Motion 32-channel servo motor controllers can support 12 voltage. So this is something I could actually do with my existing motor controller boards. And they're fast, but they're $425 per motor. I'd need a couple of them to power a Bicep. So that'd be $850. It's still way cheaper to go with these, which is only $67 for about the same force. But if I get the money later on down the road and I really want to make the robot powerful, I could, let's say I put like 5 of those into the Bicep, we'd be looking at over 300 pound-inches of force. So if you come up to here, if you're going to be able to get 300 pounds of force with the Bicep, that would lift a 30-pound weight. A 30-pound bicep curl is about an amateur bodybuilder like myself would do at the gym. That's impressive if it can lift that. It will really be close to my type of musculature then, and for it to be able to do what I can do physically would be ideal to me.